Okay, so let's take a look at this exercise. It is number 15 of the ones you guys are doing. It says find the derivative of the function b at r equals 3. So let's take this step by step. The first thing you want to do is find this, find the derivative. That thing should be absolutely easy. In case you have any questions, you can just tell me at any point, all right? The first thing you should do is find the derivative. So let's do that really easy. But look at this. As a denominator, we have r. Man, as a denominator, we have r. So we don't want to have that right there because so far we don't know how to derive this type of function. So we want to put it in denominator. What we want to do is volume equals, or well, b equals 4r squared plus, and in this will be 18r to the negative 1. Did you see what I did? I am not derivating yet. I am just changing the function b so that it is now the r that was in the denominator, it is now in the numerator. Since this one has a 1 over here, you can just put it up as a negative 1. Now you can derive that thing. The derivative will be dv over dr will be 8r plus, and this will be negative 18 r to the negative 2. Again, if you are having any questions, if you don't understand something that I just did, let me know, all right? So far, so good? I'm assuming yes. Cool, thank you, let's continue. So now that we just find these, now that we did the derivative, now we want to do the r equals 3. So we want to find the derivative at this point when r equals 3. Now that we had the derivative, all we need to do is change the values of r for 3. Let's do that real quick. Take the derivative and evaluate it at 3. What that means is change the values of r by 3. This will be 8 times 3 plus negative 18 times 3 to the negative 2. You have two options here. Number one, you can put this in the calculator and tell me the answer. That is the first. The second option, you can just go ahead and do this using any algebraic method that you know, all right? I'm going to do that real quick. 8 times 3 is 24. Plus, I'm going to do negative instead, because this is plus and minus. This should give me a negative. And look at this. This 3 is to the negative 2. How do we solve this? Let's take a look at this. This will be 18 over 3 to the 2. Because of the same property that we just used in here. Again, if we have an exponent that is negative, you can change it to be in the denominator, just like we did in here. This is negative. We can change the r to be in the denominator, but the exponent will be positive. And same here, the 3 is to a negative 2. We can change it to be down in the denominator, but the exponent should be positive now. So this should be pretty easy to solve. This is 24 minus 18 over 9. 18 over 9, I don't have enough space. I'm going to continue over here. 18 over 9, that is 1/2, right? I'm sorry, 2. 18 divided by 9, that is 2. So this will be 24 minus 2, and then just 22. This one should be our solution. Again, the question was, find the derivative at a certain point, at the point where r equals 3. How did you solve it? First, find the derivative, and then replace the values of r by 3. By doing so, you need to do some algebra and then get to the final solution. Is that good?
Ok, gracias, Gus.
No problem.
Gus, tengo otra pregunta pequeña.
Sure, try to say it in English, please.
I have a question. Oh my God. Okay.
Don't be scared. Nobody's looking at you. Don't be scared. Nobody's looking at you.
Oh my god. Is that in the video that I see? Yes, that you
Hmm.
sent. Is that they said that if we want to do that in the calculator, we
Yes.
must. Is the question? We must put the function as derivative or as the function that they give us?
No, look. Let's say you want to take a look at this in the calculator. How you do it? Simple. Just press the buttons that the calculator says, right? But what did you put in the calculator? Go to the screen that says y equals. This is for the Texas calculator. Texas. Texas. Is that how you write Texas? Text. I'm assuming this is how you write Texas. Sorry.
Yes.
Go to the screen where you have y equal, right? In there, you're gonna write the function. In this case, will be b equals and all of that.
Mm,
But for our example and for a correct use of our calculator, you're not gonna put b. No, b is gonna be our y, and then the r, the values of r, are gonna be our x's. So in the calculator, you're gonna write something like y equals, and then 4x squared plus 18 over x. This is what you're gonna write in the calculator. This is just for the calculator, all right? This is in the y screen. You're gonna write that, and then using the buttons in the calculator, I think it is second or alpha calculate, something like that. Calculate. When you calculate, you're gonna find the dy over dx. So tell the calculator to calculate the dy over dx, and the calculator is gonna jump from here immediately to here. The calculator is gonna do all this procedure. It's gonna find the derivative, and then it's going to replace by 3, and it's gonna just give you 22.
yes, but my question is that in the video, in the part of y, in when we put the function in y, they put the derivative form, not the function that they give us at the beginning. So yeah, they put like the in this
This one.
case this one, yeah, that one. They put that one in the calculator, and then they put all the calc process and all of that. So my question is, which of both I should put?
Like I said, just go ahead and write the first one. The first one is the one that you should write. If you want to tell the calculator to do all this process. Now, there is a second process. You can also do something else. If you want, you can tell the calculator to find the value of r for the derivative. So if that's what you want to do, you write the derivative in the calculator, in the y function. You write the derivative that you already derivated yourself using a piece of paper and a pen, right? You can write that in the calculator and then tell it to calculate when x equals 3. But there is a different process, because if you want to calculate the derivative, you write the function. If you want to calculate the value when r equals 3, you'd write the derivative. It should give you the same. Now, which one do you prefer? It depends on you. I would say just put the first one, because that way you don't have to derivate yourself. The calculator is going to do it for yourself. Again, if you put the first one, but you need to make sure what is it that you tell the calculator to do. If you tell the calculator to find the derivative, that is great. If you tell the calculator to find the value, you're making a mistake. All right? If you do so, you need to put the derivative. Better?
Okay, thank you.
No problem. Does anybody else have another question?
Gus, I have a question.
Sure.
For example, in the point 9 in 6e.
All right, let me take a look at that. 9, 6e. Six E. Point 9. The exam style question, right?
Yes.
Okay. What about it? Tell me.
How can I find the 2 points? I don't understand how to find it.
Easy. You need to work backwards. All right, so the first thing you do, I'm gonna do it in a second. I'm just gonna try to resume what is it that you need to do. But I'll do it in a second, all right? What you should be doing is take the function and then equal it to the derivative that the guys are telling you. And that is how you can find it, just by walking backwards. Let me show you. All right, let me show you. All right. There are 2 points on the curve. Can you read the function for me, please?
Y equal x power 3 minus 12x
12x plus 5. All right. So we have 2 points. We have 2 points in this curve at which the gradient is 0. So we know this. We know the gradient dy over dx evaluated at some point that we don't know, at some point should give you 0. Do you see what I'm doing? The derivative evaluated at some point that we don't know should be 0. All right, find the coordinates of those points. Should be pretty easy. All right, finding the coordinates of those points. All right, pretty simple. We know the derivative is 0. We don't know the point at which that derivative is 0, but we know there are 2 points at which the derivative is 0. So let's take that. All right, the first thing we want to do is derivate the function. This will be dy over dx. Find the derivative will be 3x over 2. I'm sorry, to the 2, right? The second power. Minus 12. That's it. This should be the derivative, right? And if we evaluate it at some point that we don't know the point, so I'm calling it k, because we don't know, I'm just saying k. This could be any point, I don't know. If we evaluate it, this will be 0, right? But this is the same as saying that 3 times k to the 2 minus 12 is 0 again, because I am saying that at a point k, if I replace it with the derivative, instead of x, I replace for a value of k, which I don't know which is, but the derivative, when I evaluate it in that point, it should give me 0. So what we have in here is an equation, a second-degree equation, a quadratic equation. Just isolate for k. Again, a couple of options here. You can use the calculator, the solver in the calculator, and find the 2 values for k. Or in case you want to do it with a piece of paper and a pen, this is how you do it. Let's try to isolate this. Let's begin little by little. This is 3k to the 2 minus 12. It should give you 0, right? And we want to isolate this. Pass this 12 to add. This is 3k squared equals 12, right? Pass the 3 to divide. So k squared equals 12 over 3. And I don't have enough space, so I'm going to continue over here. Let me just move real quick over here. There we go. K squared will be 4, right? So k squared equals 12 over 3, which is 4. Then tell me the 2 values for which k should be the square root of 4. 2 values. The square root of 4. That means we have a positive value of 2 and a negative value of 2. Again, the question said, there are 2 points at which the derivative is 0. Well, the 2 points are when k equals positive 2 and negative 2. Better? Isa?
Sorry. Y entonces, entonces, ese sería igual para todos los casos, o sea, siempre habrían 2 respuestas.
In this case, mira, ¿cómo sabemos que sí hay 2 respuestas? Mira el poder de la respuesta, de la derivada. Esto estaba al cuadrado. Como está al cuadrado, yo sé que esta ecuación, si la igualo a 0, esta ecuación tiene un máximo de 2 respuestas reales. Puede que no haya respuesta, o tal vez hay una, o tal vez hay dos, no hay más. O 0, o 1, o 2, porque está al cuadrado. Entonces, por eso sé que si yo resuelvo esta ecuación, tal vez me da una respuesta, o tal vez me da 2. En este caso, porque el ejercicio nos sapió la respuesta, sabíamos que eran 2. Tal vez si yo hubiese puesto aquí en vez de negativo 12, mira, si yo hubiese puesto aquí un cambio tan fácil como un más, en vez de negativo 12 hubiese puesto más 12. Aquí hubiese quedado menos 12. O sea que aquí hubiese quedado menos 4. Y aquí me hubiera quedado la raíz cuadrada de negativo 4. Y no tenemos respuesta real para eso. Entonces, en este caso, la respuesta sería, no existen. No existe valor k para el cual la derivada es 0. No existe. Con un pequeño cambio. Entonces, sé que son 2, pero de pronto, en un ejercicio diferente, nos da que la derivada no es a la 2, sino es a la 3 o a la 5. Bueno, pues eso cambia mis respuestas. Porque si es a la 3, ahora puedo tener una respuesta, 2 respuestas o hasta 3 respuestas. Inclusive puedo tener ninguna respuesta. ¿Me hago entender? Entonces, ¿cómo sabes cuántas respuestas tienes? Depende del exponente de la derivada. ¿Qué depende del exponente de la original? ¿No? Mira, esto era la 3, por eso fue que la derivada nos dio a la cuadrada. Si aquí la derivada nos hubiera quedado a la 1, por ejemplo, pues sabemos que de pronto tiene solo una respuesta. Así es como.
Ah, listo. Gracias, profe.
Bueno, la esencia es la misma, ¿listo? Trabajas al revés, mira. En este caso no nos dieron un punto para encontrar la derivada, no. Nos dieron la derivada para encontrar un punto. Y trabajamos al revés, es la misma esencia, ¿está bien?
Bueno, listo. Gracias, profe.
No problem. Does anybody else have another question? No, we all good? Cool. Then continue working.